Hello all, welcome to this session. In this session, I am going to answer software testing interview question 67, that is explain equivalence class partitioning with example. Let me answer. Equivalence class partitioning is one of the black box test design technique. So what is the purpose of this equivalence class partitioning? Why we have to use? The purpose of using this equivalence class partitioning black box test design technique is to filter out the finite possibilities of test data from the infinite possibilities of test data. Okay, from the infinite possibilities of test data that we can use for testing, from that we have to filter out the finite possibilities of test data without compromising the risk. Okay, without compromising the risk. That is called as equivalence class partitioning. So if I explain about the equivalence class partitioning with example, it will be more clear for you. Okay, I am going to explain this equivalence class partitioning black box test design technique with lot of examples so that it will be more clear for you. Fine. So how this equivalence class partitioning is going to, okay, is going to filter out the finite possibilities of the test data out of the infinite possibilities of test data without compromising the risk is something I'm going to show you with these examples. Okay. So after this, you will understand this line and you will understand the equivalence class partitioning without any problem. Fine. Let's start with one of the example, that is age field. So let me open this paint. So here I'll draw a diagram. Okay. So here guys, let's say there is a text box field and which has a label like age. Okay. There is a age with the age label. There is a text box field. This particular text box field accepts the age from some age value to some age value. Like for example, from 12 years to 25 years. Okay. This is the range. Okay. So this particular age box field will only accept the age from 12 to 25. So in such kind of cases, okay, in such kind of cases, if I have to test this age text box field, so if I am not using this equivalence class partitioning, what is the problem you are going to face? Okay, first I will not show you how to use equivalence class partitioning. Without using the equivalence class partitioning, if I try to test this age, how many possibilities are there? Let's see. How many possibilities of the test data is there? Let's see. Infinite possibility will be there. Okay, so if I have to test this without applying the equivalence class partitioning, infinite possibilities of test data will be there. So how? So I'll first start with 12 guys. Okay, I'll enter 12 into this age text box field. It should be accepted. Then I'll enter 13 into the age text box field and it should accept. Then 14, then 15, then 16, 17, 18, 19, 20, 25. Okay, 20, 21, 22, 23, 24, 25. All these values which are in the range should be accepted, right? It has to be accepted. If it's not accepted, we'll report a defect anyhow. Okay. So how many possibilities of the test data we got? From 12 to 25, we got almost like 12 to the 24, around okay, around 13 amount of test data we got. Okay, 13 test data we got. But this is not enough, guys. Okay, what will happen if I give 11 here? If I try to enter 11 into this, which is less than 12, what will happen? It should not be accepted by the age. That means I have to enter the 11, right? Here already we got the 13 possibilities of the test data with a positive range, with a possible range, accepted range. Apart from that non-accepted range also I have to test. That is I have to test 11. Then I have to test 10. Then I have to test 9 and so on infinite. Okay. So minus 5, minus 10 and so on infinite. This list will not end guys. Okay. The test data list will not end. So infinite possibilities of invalid data is there here. This is valid data. This invalid data. Okay. 13 sets of invalid data in this example. And infinite possibility of invalid data is there. On the other side, guys, okay, if you take more than 25, that is 26, 27, 28, and so on, there is no limit here. Okay, this is infinite till infinite number. And here also we have the infinite possibilities of the test data. Not only this, what if you try to enter some alphabets? It should not be accepted. You can imagine, right, how much amount of infinite data is possible if you give alphabets, words, and sentences. If you enter here, right, that will infinite possibilities of invalid data coming to the alphabets and all. Okay, alphabets, etc. What about symbols? Infinite possibility of symbols and combination of symbols is there. That means there is how much possibility of test data that I can create for testing this age text box field. For testing this age text box field, which can accept the values from 12 to 25, I can prepare infinite possibilities of test data. But is this a good approach? No, we cannot test, right? Even though I give you 1 year also, you cannot complete the testing, because this much amount of data, if you keep on entering, after completing the year continuously 24/7, if you enter also, you will not be able to confirm that each text box field got tested properly. That's the problem. To overcome this problem, there is a black box test design technique known as equivalence class partitioning, using which we can filter out, okay? We can filter out finite possibilities of test data out of these infinite possibilities of test data, okay? Without compromising the risk, without compromising the problem that a defect will be missed, okay? And that is the equivalence class partitioning technique, okay? Test design technique, black box test design technique. So in case of age text box field, okay? So for example, the same text box field I am writing here, guys, age text box field, okay? That is a text box field with the age. So if I apply the equivalence class partitioning for this age text box field, how many partitions you will get, I'll explain now, okay? Let's say this will accept the age from 12 to 25. In this case, we'll first create a valid partition, okay? Equivalence class partition means what? If I divide these three words here, okay? Partition means, you know, right? You have to partition, okay? Partition mean what? Partition means what? Partitions means you have to partition, you have to separate, okay? Separation is nothing but the partition, right? This is one partition, this is another partition, this is another partition, this is another partition, this is another partition, and so on, okay? These are the different partitions. So partitions, these are nothing but the partitions, separations, okay? Partitions are nothing but separations. Equivalence means what? Equal means equally you are dividing, okay? You are making the partitions equally. This partition is equal to this partition, this partition is equal to this partition. That's why the name has given as equivalence class partitioning, okay? Different classes, okay? This particular partition is a type of the partition is different. The type of the partition is different. That's why they are saying class here, okay? Every partition has its own type. That's why they are saying class. Equal class partitioning, okay? Kind of equally we are partitioning, and each and every partition of different type. That's why the name is coming as equivalence class partitioning. So if I apply the equivalence class partitioning to this age field, which is accepting the values from 12 to 25, instead of using this infinite possibilities of test data, I'm going to filter out this infinite possibility of test data to the finite possibility of test data. How? First, one of the partition, I'll name that as valid partition. In this valid partition, what is the accepted range, guys? What are the accepted values in this age field? 12 to 25, right? Any of the random value you take, okay? From 12 to 25, any random value you take. For example, if I take 19, okay, 19 falls in between this 12 and 25, right? In this range, 19 comes in this 12 and 25. If I enter 19 into this age field, the age field will be accepted. The age field will be accepted, right? The 19 value will be accepted by the age field. So I will not test with 12, 13, 14, 15, 16. I will not test with all the values. I'll only take one of the value in this range and take that as valid partition. In that valid range, I will take only one value, which is of valid type, and give that. This is a test data, guys. Okay, I filter out this valid range into this only single data. Okay, single valid data. After that, I'll give another one as invalid range. Invalid range means which is greater than 25. Okay, starting from 26 to infinite number, any random value you take. Okay, any random value after 25 you take. That can be anything, guys. Okay, it can be like as simple as 75. Okay, if I give 75, which is above the 25, okay, this invalid partition is coming. So this is invalid. If I give 75 here, age will not should not accept, right? So one of the test data I got, I will not test all the infinite numbers. Okay, I'll only go with one of the random value out of this infinite range, infinite invalid range after the 25. And below the 12 also, I'll get infinite possibilities 11, 10, 9, 8, 0, minus 5, 9, minus 10, and so on. Okay, infinite. So from that invalid range also, from that lesser than 12 infinite range also, I'll only take one value. Okay, let's say I'll take some value like minus 6. Okay, minus 6 I'll take randomly. Fine. So here we got three partitions already. One valid partition, two invalid partitions. On the top of that, if you still want to create more partitions, it's okay. You can create this. Okay. You can create more partitions. For example, what will happen if you give alphabets here? If I give ABC, it should not accept, right? Only numbers should be accepted. So ABC will be restricted here. And what about if you enter symbols? Let's say symbols. Okay. Symbols. If you try to give some symbols here, dollar. Okay. Dollar hash kind of symbols, it should not be accepted. Symbols should not be accepted. Only this 12 to 25 should be accepted. So this is another invalid. So there are infinite possibilities of symbols and symbol combination, but I am only giving one random invalid test data to test as part of the symbols. Okay, to test as part of the alphabets, entering alphabets into the age, I'm giving only one random value. There are more possibilities. DEF is possible, ARUN is possible. Okay, testing is possible, everything is possible, but I'm only taking one sample data out of that random range. Okay, so what else is there? Okay, so I can give one more invalid also. I can give, let's say, out of my out of box thinking you can do, where you can give something like combination of alphabet dollar, I mean symbol alphabet and some number. If I give, what will happen? It should also not accepted. Okay, H field should not accept this invalid data also. So how many partitions I am able to create here? 1, 2, 3, 4, 5, 6. Total how much? How many sets of test data I got here? How many sets of test data I got, guys? 1, 2, 3, 4, 5, 6. Only 6 sets of test data out of the infinite possibilities of test data. If I keep on testing this infinite test data with this H text box field, more than in year also you will not be able to test this field. But if you apply the equivalence class partitioning, this entire infinite test data is filtered out to just 6 sets of test data. Six, six test data, that's it. Okay. You see how much time will it take for you to test this particular age field with these 6 sets of data, where one is valid and remaining all are invalid. Only valid should be accepted by the age field, whereas all this invalid should not be accepted. This invalid should not accepted. We are simply testing that it should not be accepted. Here, this two invalid also should not be accepted. Only this valid partition should be accepted. Okay. Then only the age text box field is working fine. So this is what is the equivalence class partitioning, guys. Okay. We can apply the equivalence class partitioning to different examples. Okay. Here, I explained you with the age text box field. What if there is a situation where in real time you have to test a field, okay, where you can enter a mobile number, okay, mobile number text field is there, which can accept the mobile number. What will be the generally the size of the mobile number is 10, right? 10 digits. For example, if I give one mobile number 912124545 6. Okay, how many digits are there here? 12345 12345. This is a 10 digit number can be entered into the mobile, because mobile number should be of 10 digit sets, let's say. Okay, a 10 digit mobile field number this is. Okay, into this we can enter the 10 digit mobile number. That's what is the testing. So here infinite possibilities are there for testing this, right? Okay, so but I'll apply this equivalence class partitioning, where first I'll create a valid partition. In the valid partition, I'll give a random phone number, mobile number, which is of the which is having 10 digits in size. Okay, a random mobile number which is having 10 digits. Okay, this is a random number I'm giving. 91212454556 is the number. One random, because there are infinite possibilities. I'm only taking one number here. What about invalid? Here, the size of the mobile number is how many digits? 10 digits, right? 10 digits. What if I give more than 10 digits? That will be definitely invalid, right? If I give something like this and add 1 to here, append 1 to here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, total 12 digits are there. 12 digits should not be accepted by this mobile number field, okay, which is of greater size than 10 digits. Here the size, guys, okay, the size of the number is important here. Okay, the size of the number that you are trying to enter into the mobile field is important. Here it's not about the range of values, it's about the size of the number is important. How many digits the number is there, that is important here. Okay, in this example we have to create the equivalence class partitioning with the help of the size, guys. Okay, size of the numbers. So here if I give 12 digits, it should not accept. 10 digits it should accept. Again here if I give some less number of digits than 10 digits, for example if I give here 3 1 2, will it be accepted? It should not accept. Mobile number should be of 10 digit size, but here only 3 digits, it will not be accepted. That's why it's invalid partition. On the top of that, guys, we can test by entering some text symbols into this mobile number field. Okay, but we can create few more invalid partitions here. One more invalid partition I'll create here. Like this, I'll create invalid partition where I'll try to enter some alphabets, guys. Okay, so already the type of the data is what here? Number, right? The size of the data is 10. The type of the data is number data. Number data size is 10. Here number data wise we created the partitions, but here the type I am changing. I'm changing the type from numbers to alphabets. Okay, A, B, C, D, E, F, G, H, I, J. How many are there? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 are coming. Okay, alphabets. The size is 10. Okay, this particular alphabets are matching the size, but these alphabets are not digits. So that's why it is invalid. Even though size is 10, but still these are alphabets, so it should not be accepted. This much is enough, guys. You don't have to go beyond that. Okay. So invalid. Some symbols I'll give, but I'll stick to size 10. But here instead of digits, I'll give symbols. Okay. $X exclamatory mark at the rate symbol. Okay. Dollar percentile, like this. Some symbols I'll give. Okay. Of size 10 I'll give. Okay. The number of characters 10 I'll give, but they are not digits, but they are symbols. 1 2 3 4 5 1 2 3 4. Two more I have to give. Let's say I'll give like this. Okay. So this is of size 10, but the problem is here digits are there, but you are giving what? Symbols, which will not be accepted by the mobile number field. So how many sets of data I got for testing this mobile number field now, which will accept the 10 digit size of number? I got 5 partitions, 5 sets of data I got. Okay. Instead of testing this mobile number field with infinite sets of data, you're going to test this particular mobile number field with just 5 sets of data. Okay. I'm giving more and more examples so that you will get used to equivalence class partitioning, guys. Okay. You'll be able to answer the this particular question if it comes in the interview well, if, with these examples. Okay. So like that, other things are possible, guys. Only positive numbers, only credit cards. Okay. 10 to 20 alphabets. Lot of examples are there here. Okay. Which is a combination of ranges and size. Lot of things are there. Here it's a range. Okay, this is a range. Just 12 to 25 is a range. But here mobile number is a field of which type? Size type. Okay, size and type. Type is number, right? Type is number. Size is 10 digit size. Okay, 10 is a size. Type is a number type. Okay, but in coming to the only positive number, already this is completed, guys. Okay, uh, this example is already completed, which has 10 digits only. Is mobile number will be 10 digits only, where both combination of size and type is already explained. Okay, we are left with 3 more items. Okay, we are left with 3 more items, where only positive numbers, only credit cards, 10 to 20 alphabets. 3 examples I am going to give you. Okay, so only positive numbers. Let me explain. Only positive numbers. Let me give only positive numbers. For example, there is a text box field, okay, which will accept, okay, there is a text box field which will accept only positive numbers. Which, okay, some number you have to enter into the text box field, but it can be any number. It should be a positive number. Okay, positive numbers are accepted. Let's say, okay, positive numbers are accepted. In that case, valid partition I'll give, and I'll give a random number here. I'll give a random number here, guys. Any random number you give for this positive number. Let's say I'll give 894. Okay, is a random number I gave. Okay, with this I will test positive number. But here I'll give an invalid partition where I'll give a negative number. Okay, minus 59. Okay, which is an invalid number. Negative should not be accepted. That's why. Okay, so here only numbers are accepted. Number means type is number, right? Only number should be accepted. In that case, what I will give? In that case, I'll give another invalid saying, what if I enter alphabets? What if I enter some alphabets? A, B, my name I will enter. It should not accept. Another invalid. I'll give some symbols. Okay. I'll try to enter some symbols as this partition data. I'll say, okay, some symbols I'll enter. All these are invalid partitions, right? All these are invalid partitions. So here, how many sets of partitions we got? How many sets of data we got? Only 4 sets we got for testing this positive number field. Okay. So this is how we test a text field which will accept the positive number. Now we have the credit cards. Okay, coming to the credit cards. Let's say there is a, okay, there is an application functionality, guys, where only credit card should be accepted. Okay, there's an application functionality where only credit card should be accepted. Other things should not be accepted. So here you can only select the credit cards. Okay, in that particular fields or whatever it is, you will only select the credit cards. Okay, but other things should not be accepted. So here what you will do here is only credit card means what you will do here is first you will create a valid partition here. Okay, for testing this using the for right, filtering out the finite possibility of data with the from the infinite possibility of data. What I will do here is, out of all, there are different bank companies, right? For credit cards are there, like HDFC Bank credit card is there, ICICI Bank credit card is there, Axis Bank credit card is there, SBI Bank credit card is there, S Bank credit card is there. Different banks credit cards, American Express credit card is there, Citibank credit cards are there. But I'll only take one of the credit card I will take. Okay, only one. Let's say HDFC credit card I will take. Okay, HDFC credit card as a sample. Okay, as a sample data for test data for this valid category, I'll only take HDFC credit card by ignoring the all other type of credit cards. Okay, this is how I test. Then invalid, if you apply equivalence class partitioning to this particular functionality where credit cards can be selected and the other payment options are not selected, in that case, here invalid is debit cards. Okay, I'll take one, let's say Axis Bank, Axis debit card as a sample test data I'll take to test this invalid category, which should not be accepted here. And other invalid I'll take. This time, instead of debit card or some cards, I'll take a net banking. Okay, I'll try to pay using the net banking. I'll take some ICICI bank net banking. Okay, I'll try to pay via it should not be accepted by this functionality. Okay, because only credit cards are accepted, so net banking should not be accepted. Then another data what I will get, invalid partition, what I will get, guys. So cash on delivery, okay, COD should not be accepted. Like that, all these invalid partitions we can create. How many partitions we got? 1, 2, 3, 4. One more invalid partition you can think of, right? In real time, what is another partition you may expect? Another partition you may expect is UPA, right? Okay, that is you can use some wallets, UPAs, and all those stuff. Okay, UPIs and wallets like like Google Pay and whatever it is. Okay, so here instead of writing UPI here, I'll say Google Pay otherwise. Okay, I'll write Google Pay. That will be the correct data. Here we have to give the test data, guys. Okay, we should not be randomly writing that. I'll say Google Pay. Okay, Google Pay. I'll say simple, done. So 1, 2, 3, 4, 5. Total, how many sets of data we got? 1, 2, 3, 4, 5 sets of data. With this, we'll complete the testing. This is how we can filter out the finite possibilities of test data out of the infinite possibility of the test data by applying the equivalence class partitioning. Now, last option, guys, last example I'm going to give you for making you guys understand what exactly is equivalence class partitioning, how many situations you will get in real time where you can filter out the data using this equivalence class partitioning. Last example I'm going to give you, that is 10 to 20 alphabets. Okay, 10 to 20 alphabets. So let's say there is a field, guys. Let's assume that there is a field. Okay, let's assume that there is a field which can accept the test data. Okay, which can accept the data which is having 10 to 20 alphabets. Okay, 10 to 20, 20 to 20 alphabets can be entered. Okay, so here size is there, right? One of the item is range. Sorry, 10 to 20 means it's not size, guys. It's the range, right? 10 to 20 range, size and range combination. You can say it is a range, size, and type combination. Okay, this is a combination of three things. Here 10 is the size. Okay, allowed size is 10, allowed size is 11, but that size is in the range. Okay, it's kind of complex situation where size is actually specified in range, and the type is also specified as alphabets. So if I have to give this valid partition here, if I have to create a valid partition for testing this particular text box field which will accept the 10 to 20 alphabets, then first type is important, alphabets is important. Okay, and what should be the range and size of that alphabets? The size of that alphabet text that you are trying to enter into this field should be in the size of 10 to 20. I'll take some random one, 13, let's say. Okay, I'll create something like this: A, B, C, D, E, F, G, H. Okay, how many came already? 5, 8, 9, 10, 13. Okay, size 13 I gave. 13 size, which is in the range, right? 10 size range to 20 size range. 13 is in the range of 10 to 20, and size is also matching. Type is also matching. Alphabets are matching. So this will be accepted, valid partition. If I have to give invalid partition, what I have to give? So I'll give out of this range. Okay. So here 13 is there, but I'll give out of the range. That is A, B, C, D, E, A, B, C, D, E, A, B, C, D, E, up to this 15, A, B, C, D, E, 20, A, B, C, D, E, 25. 25 should not be accepted, right? That is invalid. This side also I'll create an invalid based on the size and range. Okay, based on size and range, I'll give an invalid thing. That is, I'll give just ABC, which is less than 10, right? Less than 10 size. And also it's not falling in the size range. So ABC will not be accepted. So invalid. And on the top of that, what if I give valid size range, but invalid type? That is, I'll give something like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. How much size this is? 10. 1, 2. Okay, something like this if I give 12, size is 12, which is falling in this range, but type is different. So it will be invalid. Another one, another invalid. I'll give something like this. dollar hash at the rate dollar, okay, exclamatory mark and hash dollar percentile and how many came already? 1, 2, 3, 4, 5, 6, 7, 8, 9 came. 9, 10, 11, 12, 13, 14, 15. Okay, 15, which is in the size only. Okay, which in the range. The size is matching, but type is not matching. Alphabets here, symbols are there. That's why it's invalid. How many sets of data we got for testing this text, this particular field? 5 sets of data are enough. You don't have to give infinite. You don't have to test this field with infinite possibilities of test data. Rather, you can use this filtered out. Okay, finite possibilities of test data out of the infinite. We have filtered out using the which test design technique, black box test design technique. That is none other than the equivalence class partitioning test design technique. So guys, with these examples and all, now I hope that you'll be able to easily answer this question if you get this in the interview. If someone asks you in the interview, like explain equivalence class partitioning with an example, you see, with this session, you should be in a position to answer it at any cost, guys. Okay, there is no other way of escaping. So many examples I gave, right? So many examples I gave from the beginning and end. Okay, too many examples I gave. Whatever the example you get in the interview, you will be able to answer with this explanation, right? No matter what, you can answer the question now. So that's all for this session, guys. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye.